Okay guys, we're working on the Unit 2.4 review. It's front and back. Every single one of these questions you will need to know for your quiz next class, so please pay attention to every single problem. And understand that it's all based off the structure. Whatever the triangle is given to you, that's what method you use. Okay, so we'll start with the first one, simplifying following radicals. Remember, when multiplying numbers together, we can only multiply numbers that are outside the radical together and numbers that are underneath the radical together. So 2 times 3 gives me 6, and then 5 times 20 gives me the square root of 100, because 5 times 20 is 100. Now, if you can simplify, please do. 6 stays because it's not a square root, and the square root of 100 is 10. Now, because both these are outside the radical, we can multiply them together, which means the whole thing simplifies to 60. Number 2, simplify the square root of 300. We'll take a look what I wrote. The perfect squares at the top are any of these squares of 100, or factors of 100. Well, 25 is, but remember, to find the biggest one will make it only one-step equation. So if you notice, 100 is a factor of 300. So I'm going to split that up into square root of 3 times square root of 100. Remember to keep the square root symbol until you take a square root. Square root of 3 stays, and the square root of 100 simplifies to 10. We always like to write our number outside the radical first, so it's 10 square root of 3. Okay, number 3. If you like to simplify them separately, you can, or you can combine like terms by simplifying the fraction 16 over 150. I'm just going to simplify them separately first. So the square root of 16 is 4, and then what's a perfect square that's a factor of 150 would be 25. 25 times 6, so I get 4 over 5 times the square root of 6. So this answer will be good for now. Remember, if you want the extra credit, you have to rationalize the denominator. So I'm going to take that fraction and multiply by the square root of 6 over square root of 6. So my numerator, I get 4 times the square root of 6, because none of them can combine. And then we can multiply the square root of 6 times the square root of 6, which gives me 5 times the square root of 36. Now let's simplify that. So I get 4 times the square root of 6 over 5 times, well, the square root of 36 is 6. And now we have 4 square root of 6 all over 5 times 6, which is 30. And now we can actually simplify this fraction. What goes into both 4 and 30? Well, 2 does, so I'm going to divide the 4 by 2 and the 30 divided by 2. So I get 2 root 6 all over 15. Okay, now we start getting into our triangles. So I have a right triangle with an altitude drawn, so I need to compare my small, my medium, my large triangle. Well, I'm going to take my small, which has 3 and x, and my medium, which has x and 9, and I'm going to write the proportion. Remember that we have a geometric mean. The x's are across from each other, so I get x squared, and 9 times 3 is 27. Square root both sides. Go back to your perfect squares. Which one of these is a factor of 27? Well, 9 is, so I can split this up into the square root of 9 times the square root of 3. And the square root of 9 is 3, and the square root of 3 can't be simplified, so I leave it as square root of 3. Number 5. Well, I have 2 sides in a right triangle, and I need to figure out the third one, so Pythagorean theorem. 2 squared plus 4 squared, 4 squared equals, well, we don't know what this is, so if you want to call it x, you can, x squared. So I get 4 plus 16 equals x squared. 20 equals x squared. Square root both sides. Go back to your perfect squares. Which one of these is a factor of 20? Well, 4 is, so I can split it up into the square root of 4 times the square root of 5. The square root of 4 is 2. The square root of 5 cannot simplify, so I leave it as 2 times the square root of 5. Number 6. We're given a 45-degree angle, so now we can use our 45-45 right triangle. Well, the pattern between the leg and the hypotenuse is multiply by square root of 2. So now I need to go reverse order. So it's actually going to be dividing by square root of 2. So I take 12, divide by the square root of 2. Remember, this answer will work, but I like to rationalize my denominator. So I'm going to multiply by square root of 2 over square root of 2, which gives me 12 square root of 2 over the square root of 4, because I can multiply these two. So now I get 12 square root of 2, and the square root of 4 simplifies to 2. Simplify the numbers outside the radical, and I get 6 square root of 2. Well, that means my y is 6 square root of 2. That's this side. And remember that the 2 legs of a 45, 45, 90 have to have the same length. So that means the other one is also 6 square root of 2. Okay, number 7. Given 2 sides in a right triangle, we got to go back to the Pythagorean theorem. Well, we have x squared plus 15 squared is equal to 21, because that's our hypotenuse. So I get x squared. 15 squared is 225. And 21 squared is 441. So I need to get x squared by itself, so I'm going to subtract 225 from both sides. So I get x squared equals 441 minus 225, which is 216. Square root both sides. So x equals, let's see if it's a perfect square first. It is not, so we need to find a factor of 216 using our perfect squares. Well, 216 divided by 4 does work, 54. But then can we split that up even further? 54 is 9 a factor of 54? It is. That means there's a bigger perfect square that's a factor of 216. What about 216 divided by 36? Ooh, there it is. So we get the square root of 36 times the square root of 6. So x equals, well, the square root of 36 is 6, and the square root of 6 can't be simplified, so it stays as 6 square root of 6. Okay, number 8, we got our 30, 60, 90. Well, the relationship between the shorter leg and the hypotenuse is multiply by 2. So to go back to the shorter leg, we have to do the opposite, which is divide by 2. So 15 divided by 2 gives me 7.5. That's my shorter leg, my x. If you want to keep it as 15 over 2, you can. And then the relationship between the shorter leg and the longer leg is multiply by square root of 3. So I take the shorter leg, which is 7.5, and I multiply by square root of 3. And you are done. Last but not least, a little bit of trig. We need to find the sine ratio of angle D, the cosine ratio of angle D, and the tangent ratio of angle D. Well, angle D is up here, so I'm going to put a theta there. Label my opposite, my adjacent, and my hypotenuse. Sine is opposite over hypotenuse, so that is D over E. Cosine is adjacent over hypotenuse, so that is R over E. And lastly, tangent is opposite over adjacent, which is D over R. All we're asking is the ratio of sides. Okay, next page. Question 10, 11, and 12, and 13 are all very simple on the calculator. Type in sine of 38 because we're solving for a side length, which is a 0.616. Then tangent of 68, which is 2.47. Now, when we're solving for an angle, we use inverse. Okay, so second tangent of 1.432 is 55.07. This is an angle, so I'm going to put my degrees there. And then inverse sine of 0.5 is 30 degrees as well. Okay, so these two we use inverse because we're solving for an angle. Okay, last 3 questions are word problems. Sketch a picture to help solve the problem. Sketch a picture. It says the perimeter of a square. Well, I'm going to draw a square, and we know that if it's a square, all 4 sides are the same. So if they all add up to 24 centimeters, to find each side length, just divide by 4, and that gets me the side lengths. So we have 6 centimeters, 6 centimeters, and all of them are 6 centimeters. But then it says find the length of the diagonal. So I could take the length of a diagonal. I know that there's right angles in each one. 2 different ways to do this. You have 2 sides in a right triangle. You could use Pythagorean theorem. 6 squared plus 6 squared equals c squared. Or if we know that the 90-degree angles are cut in half into 45, 45, 90, the relationship between the legs and the hypotenuse is multiply by square root of 2 in a 45, 45, 90. So the diagonal must equal 6 times the square root of 2 centimeters. If you were to do Pythagorean theorem and simplify using your perfect squares, you'd still get 6 square root of 2. Okay, number 15. A tree casts a shadow. Here's my tree. Cast a shadow that's 86 feet. Nice. Find the height of the tree, so let's label this as x feet. If the measure of the angle sun's rays makes to the ground is 32 degrees, so the angle that's created, it's a right triangle because it's a tree that's perpendicular to the ground, is 32 degrees. Okay, so here's my angle. If you want to label that as theta, there's my angle. So let's label. We got opposite, because it's across from. We got our hypotenuse, and we have our adjacent. Well, we have SOHCAHTOA, because we're given a 32-degree angle, which you can't use 30, 60, 90, or 45, 45, 90, so we have to use right triangle trig. Well, If we are solving for the opposite and we're given the adjacent, that means we have to use tangent because we don't know the hypotenuse. So let's set up our equation. Tangent of the angle, which is 32 degrees, equals the opposite, which is x, over 86, which is the adjacent. Tangent of 32 degrees gives me 0.625 equals x over 86. Remember, to undo division, we have to multiply both sides by 86. So I'm going to take 0.625 multiplied by 86, and that gives me 53.75. That's a 5 right there. Okay, and that's my x, but remember we're talking about a height of a tree, so let's put our units in there, feet, and there's the height of our tree. Last question, remember to draw a triangle, picture every time, just to make it very clear. A 32 degree or foot tree casts a 70-degree shadow, or 70-foot shadow, sorry. And then a building, there's my building, whatever, here's some windows. We don't know, which is x, casts a shadow of 114 feet. How tall is the building? Well, we have two similar triangles because they're both 90 degrees. Okay. So, let's set up a proportion. I'm going to go height over shadow equals height over shadow. So I'll start with the tree. The height of the tree is 32 over 70. And the height of the building is x, and the shadow is 114. Let's cross multiply. 32 times 114 gives me 3,648. And cross multiply here gives me 70x. So I'm going to divide both sides by 70. So I get, for my height of the building is 52.114 feet. Okay, make sure you check each one of these questions out. You can do them. If you have any questions, please come in and talk, and we'll get all this figured out. Good luck.